All right, welcome to 12.8 Quadratic Formula Day 2. All right, so you should have memorized the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So it says find the roots using the quadratic formula. We need the quadratic formula when the roots are irrational. So we're going to make this equal to 0, right? And we're going to write x equals, e is negative 7, so positive 7, plus or minus the square root, negative 7 squared, 49, minus 4, times a, which is 3, times c, which is 1, all over 2 times a again, 3, equals 7, plus or minus the square root of 49 minus 12 over 6, which equals 7 plus or minus the square root of 49 minus 12 is 37. Square root of 37 over 6. Those are the two roots. All right. So how many roots are there? There are two. We learned earlier that parabolas can cross the x-axis twice, have two roots, come down and touch it once, have one root, and never cross the x-axis and have no roots. How do you tell? You actually don't have to go past b squared minus 4ac. If that's negative, you're going to get the square root of a negative number. So if you get the square root of negative 17, doesn't matter, you can't do it. And it means it has no roots. So let's see what happens here. We have x equals negative b, 4. But you really don't have to do that part. Plus or minus the square root b squared, 16, negative 4 squared, minus 4 times a, which is 2, times c, which is 3. 4 times 2, I'll put the 2 times 2 on the bottom, but this is all you really need to look at, because this is 16 minus 4 times 2 is 8, times 3 is 24. It's 16 minus 24 in there, which is the square root of negative 8, which is imaginary, and that means this has no roots. All right, it has imaginary roots, but we're going to say no real roots. Let's say no real roots. All right. Right? It doesn't cross the x-axis. So you can stop once you know that is negative. In this case, when we do negative b plus or minus the square root of b squared minus 4ac all over 2a, let's see what b squared minus 4ac is this time. B squared is negative 4 squared, 16, minus 4, a is 4, c is 1. This time we get 16, the square root of 16 minus 16, which is the square root of 0, which is in fact 0. That means, doesn't mean there's 0 roots. It means there's 1, because look what would happen. So b was negative 4. So the whole thing, right, the whole thing, to go back to the beginning, negative b would be 4. Now we have plus or minus 0 all over 2 times 4. Well, this is 4 over 2 times 4, which is 8, which is 1/2. So this better have a root at 1/2, 0. It has one root at the point 1/2, 0. All right, so what this 0 means, doesn't mean no roots, it means one root. And that's what the plus or minus part all disappears, right? That's how you only get one root. All right, so in this one, you're going to have to do a little simplifying. Let's see that. We haven't done that in a while. X equals negative b, negative 5, plus or minus the square root of b squared, 25, minus 4, a is 1, c is negative 5, all over 2 times 1, which is 2. So we get negative 5 plus or minus the square root of 25 minus, notice I always write it this way, 4 times negative 5 is negative 20, minus negative 20 all over 2. So you get negative 5 plus or minus the square root of 45 over 2. Remember that we learned earlier in the year that you're not allowed to leave the square root of 45. The square root of 45 has one of these numbers in it. You have to remove it. Yes. So it has the square root of 9 and the square root of 5. So the correct way to write this is negative 5 plus or minus 3 times the square root of 5 over 2. Those are the roots. So this had two roots, but you had this extra step of simplifying the radical or the square root. A radical is another name for square root. Sometimes we're going to have to remove a common factor. Yes, all these things we've learned are coming together. X equals negative b, negative 4, plus or minus the square root of b squared, 16, 4, times a, which is 1, times c, which is negative 6, all over 2 times 1. X equals negative 4 plus or minus the square root of 16 minus negative 24 all over 2, which equals negative 4 plus or minus the square root of 40, right? 16 plus 24 all over 2, right? You have to simplify the square root of 40. It has the square root of 4 and the square root of 10. So it has negative 4 plus or minus 2 times the square root of 10 over 2. But oh no, even worse. It's got a 2 that can be removed, right? This is just like if you had negative 4 plus 2x. You could remove a negative 4 and 2 from there. So we're going to remove a 2. 2. We're going to remove a positive 2 even though that's a negative. 2 times negative 2 plus or minus square root of 10 over 2, and now because we have 2's, right, in each term, we can cancel. And this one simplifies to negative 2 plus or minus the square root of 10. Yeah, that's about as bad as they get. Try one on your own. So this is tricky, right? You got to get that equal to 0 before you do anything else, right? The quadratic formula works on a squared plus b squared, ax squared plus bx plus c equals 0. Sorry, I said that wrong at first. So we have to subtract 1 on both sides. Now we can use our formula. So negative b, 4, plus or minus the square root of b squared, 16, minus 4, times a, which is 7, times c, which is negative 1, all over 2 times 7. All right. So x equals 4 plus or minus the square root of 16. 4 times 7 is 28 times negative 1 is negative 28. So minus negative 28 all over 14. So that's 4 plus or minus the square root of 28 plus 16. 8 plus 16, 44 all over 14. So square root of 44 can be simplified as square root of 4 times square root of 11. So we have 4 plus or minus 2 times the square root of 11 over 14. We can take out that 2. You can do the distributive property of division right there if you prefer. But we're removing a 2, then it's 2 plus or minus the square root of 11 over 14. The 2 cancels with the 14. The 14 becomes a 7. 2 plus or minus the square root of 11 over 7. Yes, you have to simplify your fractions, right? There was a common factor of 2 in both of those. So let's practice. So here you're just stating the number of roots. When it says find the roots and state the number, so you have to do both. So we're making that equal to 0, and then we're saying x equals negative b, 11, plus or minus the square root of b squared, 121, minus 4, times 5a, times c, 7, all over 2 times 5. x equals 11 plus or minus square root of 121. 20 times 7 is 140. Whoops, that's going to be a negative number. So we're done. There are no real roots. Right? That's the discriminant. The word discriminant means discriminate, which is not necessarily bad, but we know it is a bad word. But in this case, it means to tell the difference of. The discriminant tells you how many roots. In this case, none. It does not cross the x-axis. 4 times -1, -4, times another -1, +4. So this is 4 minus 4. Oh, look at that. This turns into 0. So we have x equals 2 over -2, right? Which means there is one root, and there is one root, and it's at -1. So this, notice it's upside down, and it must hit right there at -1, 0, the one root it has. Once you get a 0 in there, you have one root. Once you get a negative number, you have no roots. Oh, what a better Easter egg than Mr. Ben looking for Easter eggs. Remember, these have to equal 0 before you can do this. Square root of 20 can be simplified to the square root of 4 times the square root of 5. I'm removing a 2. It has two roots. They are at 4 plus the square root of 5 and 4 minus the square root of 5. All right, I'll talk to you again tomorrow.